My name is Kevin Moore. I'm a product manager at Google. I work on Flutter and Dart. I've been there, it's crazy, December will be 11 years, and I've only been on the Dart and Flutter team. So I've been very lucky to work on this for over a decade. My focus on the Flutter and Dart teams is web technology. So that is our JavaScript compilers and our WASM compiler. We actually have two JavaScript compilers and a WASM compiler that are all written in Dart, which is kind of a crazy thing to compile the stuff. And then obviously all the work to integrate Flutter on the web. So I'm happy to get into some details about native integration on desktop or native things. I have some idea, but my focus is mostly on the web. And if you have any questions about me, you can go to my website, kevmoo.com. And I'm kevmoo most places on the internet, so GitHub and Reddit and all the other places. Flutter. Trying to do three things is usually tricky, and in our key term, our key phrase we use is 5 things. So we go for beautiful, fast, productive, and open on any screen. That's kind of our goal, which is pretty audacious, but I think we do a pretty good job. And later we'll talk a little bit about our customers, and I think many people agree we do a decent job. And as I was thinking of how to introduce the concepts of Flutter briefly, because I only have about 30 minutes, I'll try hard not to go over. I came down to 3 points that start with letter P, so powerful, productive, and popular. And we'll go through all 3 of these, hopefully with time for questions at the end. And let's start with powerful. A big aspect of the power of Flutter comes from Dart. Dart is an approachable, portable, and productive language for high-quality apps on any platform. It is a new language started by Google. It's actually started a little bit before Flutter. I thankfully was there at the beginning of the Dart language. And it really is the thing that gives Flutter its superpowers. So a brief introduction for those who don't know. This is the basic hello world starting app in Dart, just to get simple print. If you want some more details and more fancy things, it's a very straightforward language. So anyone who's done C# or C++, JavaScript, we have classes, you can extend. We have an underscore-based model for privacy on the classes, optional named arguments. It's a very straightforward language. We have some more fun features that I really enjoy, and actually it's interesting talking to even a Flutter crowd. Some people weren't aware of this. So the ability to handle futures and streams. This bottom function at the bottom provides a stream of integers. You'll see I'm flagging it as async star. So that means it's going to be an asynchronous function. And I can just yield options. I can do a for loop in there. And so this will just yield 1, 2, 3, 4, 5, obviously. And then at the top, I have an async function. So this is not returning a stream. It's returning a feature. And in that, I can do an await for over the values in that map. Maybe I'll do a map over my string and, change it to square values and print over those values. So this idea of asynchrony just built into the language, futures and streams, all the things you'd expect. So Dart is both an object-oriented and a functional language. The syntax is very familiar. We have a sound type system, which is a very important thing. And it's interesting because lots of times we'll get questions of why doesn't Flutter use Kotlin? Why doesn't Flutter use TypeScript? And my example here is, obviously there are benefits to using, for instance, the TypeScript ecosystem can use everything that's available in the JavaScript world. Same thing with Kotlin and Java. By having our own ecosystem, obviously we have to do some work to bootstrap our ecosystem, but the benefit there is things like soundness. And so not only do you get nice, syntactic squiggles and things in your tooling that says if you're doing things wrong or using null when you're not supposed to, we can actually use that data deep into the compilers to make sure that we generate optimized code and safe code. Just in the last year, we're fully null safe, and again, soundly null safe, which is important. If you have a computer science degree, I'm happy to get into what that really means. Futures and streams, we recently added records and patterns, which are great, and a very rich inference support for your IDEs. So it's very fast to write code. And we compile everywhere. And so whether it's on the native side, ARM, RISC-V is a recent addition, which is very exciting, x86, and on the web, both WebAssembly and JavaScript. And so we're leveraging the recent addition to the WebAssembly standard to support garbage collection. That's not available in all browsers yet. Safari is just in their tech preview, I think, for WASM GC. But that's great because we also compile the JavaScript. So anywhere JavaScript runs or WebAssembly runs, we can run Dart code, which is great. And this is actually a very important aspect too. Not only do we have a very good tool chain for doing production code, so compiling down to native code on ARM and RISC and x86, We also have a very efficient development experience. So really fast compiles, really deep introspection at runtime, really having a good developer flow. And we try to do both. So not only great production environment, but a great development environment. And Dart runs everywhere. Obviously, we talk a lot about Flutter, but people can build just straight vanilla DOM apps with it, server apps. Our package ecosystem is completely written in that. Obviously, for mobile, CLI, all the tooling in Dart is all written. All the tooling for Flutter and Dart is all written in Dart. We have compilers written in Dart. So I like this little image of all the places Dart runs. It's not just for Flutter. And we run everywhere. So, and I'll get into some examples here in a bit, but obviously all the desktop systems, iOS, Android web, and we're continuing to see more and more people really excited about our support on embedded systems. Folks like Toyota running it in their automotive systems. There's examples of people running Flutter on lanyards using embedded Linux. It's pretty cool. Here's the kind of the architecture diagram of how Flutter works. So at the moment, the C++ engine that we use, we're in a transition period. We have been using Skia. This is the engine that's used inside of Chrome, and part of this is actually being migrated to a new system we call Impeller. This is all written in standard C and C++. This combined to the native platform engine, so whether it's on iOS or Android. We do our own rendering, though, which is actually very important because it gives you not only the visual fidelity you want, but the flexibility you want, because we do render our own widgets. So we're not using an HTML renderer. We're not using, or a browser renderer. I can get into how the browser works in a little bit. We're not using native widgets. We are using our own implementation, which means you have supreme flexibility as an application author. And then, of course, what's interesting on the web is, especially now, we can compile our engine C++ into WebAssembly, and that's how we run our engine on the web as well. So the big thing here is speed. 60 FPS, very high quality graphics. I'll show some examples in a bit. But we do get to the point where you really can't tell this is not a normal app written in the normal toolkit. It's a very fast experience, but also rich. So we have full implementations of both the Apple and Google design systems. So on the Apple side, we call this Cupertino, but all the widgets you'd expect on iOS. Then, of course, on Android, we implement the Material Standard. This is an example of just switching between light and dark mode, which is pretty cool. And I would get into a demo, but our time is a little bit short. So that's just some brief points, kind of the power of Flutter. I want to talk a little bit about the productivity. So first, we keep evolving the language, which is a really exciting thing to work on. I work with some of the language design folks in Seattle, so I get to see all the work we're doing. So everyone's familiar with a switch statement. You're used to like switching over strings or numbers, right? Or maybe an enumeration. In this case, we're doing a switch statement, but we're switching over a piece of JSON, okay? And so look at the map here a second. And what we're doing is we're switching over saying, I want to match on a map object that has the key type and a value text question. And the next four things are all matching to make sure that key exists. And then they're also matching to make sure that the value that exists in that key is the type specified, one. And two is extract out those values. So you see cat, answer, body, ID. And then I can use that to new up a text question. So you imagine like the problems of parsing JSON in these kind of contexts, right? Where you're doing lots of checks. You want to make sure all the keys are there, they're all valid. This is just one example of many examples we're doing recently to drastically improve the productivity of the Dart language. And again, because we're a small team, we can move pretty fast. And this is just one example of the productivity gains. Another example is hot reload. And actually, let me show a demo. That's not the demo I want. Let's go to this guy. And let me close this. Just give me 1 second. Let me see if I can do font increase just real quick. So as I showed before, a Flutter app starts with main. This app is not a trivial app, so we're showing more than just a single line here because obviously you want to have a nice app bar and theming and some of the default behavior you have. But here's a Flutter app that's defined. Everything in Flutter is a widget, and so you can imagine like if you want to center content, you just make a center tag. And so again, there's some interesting trade-offs here. Obviously, a lot of people in the world are very familiar with CSS and HTML. It's very useful. What we found is being able to actually keep all the code in one language makes things really easy. It's just very straightforward in terms of how you debug it, how you author it. It's really nice. And so you see here, it's again a very famous demo. Let me resize just a little bit for the screen cropping here. So you see I can increment things, 1, 2, 3, 4, 5. Of course, this is a running app, so I can come in here and go, click here, piece number, please, and I'll save it. And of course, again, as in the last example, I don't have to reload the app or rewrite the compiler. It just works, and the app rebuilds and keeps state. I can even go as far as going up to the top, let's say, and say, maybe instead of, what's a good color? Let's do, blue. And change the theme of the app. And so, again, as many people are familiar, the problem with I'm going to do small visual changes to my application, I might be 3 levels deep, 3 screens deep into my application. Now I have to restart everything. Now I have to get back to where I was. For these types of changes, you should just be able to edit the code and hit save and have the app reload. And obviously, I'm showing this as an example on a desktop app right now. This works great with your iOS and Android emulators. Even if you have a device plugged in, actual physical device plugged in, you can do hot reload in those cases. And we're actually actively working on hot reload on the web, which will be coming soon. So that's an example of hot reload and Flutter. Of course, we have more than just hot reload. We have a full set of development tools. We call them dev tools. These actually are a web app that run locally and allow you to do things like inspect the UI tree of your app, inspect memory allocations, look at CPU speed, check the network calls that are happening. And actually, I'm super excited. This has been a web app for a long time because obviously installing native tools, keeping track of native tools, updating native tools is very difficult. The web makes this very easy. And just recently, we've moved it now so that we're previewing the dev tools running with WebAssembly. So instead of compiling to JavaScript on the app, we're now compiling to WebAssembly. And we basically doubled our perf for free by using WebAssembly, which is pretty great. Not only do we have developer tools, so as you're inspecting the app, but the plugins in our system also have an API that allow extensibility. So whether you're doing state management tools, there's an app called Riverpod that does this. I'm going to talk about our games toolkit here in a little bit. Plugins that plug into your system not only can offer features to the end user, but also can offer extensibility into our dev tools. So there's a whole API for how you can extend the developer experience you have for developers using extensibility in our dev tools. So we try to not only offer productive features ourselves, but give the extensibility for authors in our ecosystem to also make the dev tools much better. And of course, we have a package ecosystem. So pub.dev is the place where you get things. There's a funny joke here, I guess, kinda. Dart is the name of the programming language, and so where do you go play darts? But at the pub, which is another name for bar. So that's why we call it pub. But we have tens of thousands of packages. We have support for all the things you expect from Google, so support for Firebase, support for cloud, cameras, touch events, file upload, all the things you expect from a device, plus many, many, many more at pub.dev. So that's just some examples of kind of how Dart and Flutter are productive. And popular is kind of the last one. So let's talk about some of our customers. Supercell, is anyone familiar with the game Clash of Clans? It's very popular in the US. They had a problem where they are using a typical kind of native game engine. So I think Unity or Unreal or one of those engines. But they had lots of UI they wanted to share across Android and iOS on their mobile apps, and they had to rewrite it many times. And so they kept their, I think, Unreal-based game engine, but then used Flutter to integrate kind of user management, authentication, your friends list, and all those things. And they've been delighted. So they've actually deployed now on 4 of their big apps. These are top 100 game apps in the US, are all now using Flutter for the shared code. A favorite example of mine, this is a slide I made when I spoke at Barcelona earlier this year, is Google Maps and Google Earth. I'm sorry, not Google Maps, Google Earth, different teams. So Google Earth also has a problem. They have this really powerful 3D engine that lets you fly around the Earth, if you are familiar. But they have all this UI. On the side, you want to show details about the places you're visiting, UI to keep track of favorites or edit properties and things. And they had to re-implement that 3 times for iOS, Android, and the web. And obviously, they could compile their 3D engine to WebAssembly to run the web. And so what they were able to do is actually remove all that custom code across 3 platforms and just use Flutter. So now they went from having basically 3 separate teams moving very slowly to try to keep all their UI in sync. And now they have one UI team that can keep all this code working by using Flutter, which is great. Just in the last month, we announced that LG's WebOS, this is actually a misnomer. It's not using Flutter's web support. It's actually using Flutter's Linux support. But talking about the extensibility of Flutter, the official development experience for LG WebOS upcoming with their devices, TVs, and other things is Flutter. And they love it. great memory use, great developer experience, a great ecosystem of things. So I'd recommend you looking for LG WebOS and Flutter. There's an announcement, I think, from this summer. Their entire development ecosystem is recommending Flutter for this experience. And so not only are they the platforms that Google supports on our team, but many companies are looking at using Flutter and developing it for their own platforms. Toyota is another one. Another group that we discussed this summer was announced in the spring is Universal Studios. This is obviously a big amusement park chain that exists in the US. Both their Android and iOS apps have all completely moved to Flutter, and they love it. Again, one development team targeting 2 platforms. They're delighted. We are the most popular cross-platform framework in the world. So just recently beat out React, which is super exciting in the last couple of years. Across all offerings, at least according to a few surveys, by far the most popular platform for this case where you just want to deploy to many screens without having to have many teams and many code bases, one code base. And China by far is our second biggest community in the world. So there's a lot of companies in China that are betting on Flutter. In fact, I'd recommend you going to flutter.dev/showcase here. Alibaba, Tencent, a number of others, Google Earth, Google Classroom. We have dozens and dozens of companies who are betting their business on Flutter, and they've had a lot of success in it. So I hope you do too. So I talked about powerful, productive, and popular. But again, trying to keep my talk short, half an hour, doing an introduction is really hard. So there's a bunch of things I really wanted to talk about and just didn't have the time. 3D support is coming, and actually I recommend you go just Google for Flutter 3D. A bunch of the work we're doing with our Impeller engine is enabling great support for doing 3D stuff. There's I forget the name of the package. Find me later, I can tell you. Doing some amazing things with 3D. Right now this works on mobile and desktop, and we're having some discussions about getting it working on web, which is super cool. We have a games toolkit. People are actually finding Flutter to be a great place to write casual games. And so we have a number of companies that are shipping casual games with Flutter. Check out the toolkit there, flutter.dev/games. And one of the features I'm most excited about is metaprogramming. So we're actually actively working on a metaprogramming feature. We call it macros in Flutter, which allows you basically to write code that writes code. And we think that'll dramatically improve the productivity that you have as Flutter developers. So if you want to read what's happening there, or coming soon, dart.dev/language/macros to learn more. And of course, because this is an open source conference, it's important to note we're 100% open source, and we have been for years. So all the code for both Dart and Flutter is all on GitHub. We have hundreds of external contributors. We get pull requests every day. It's spectacular. So we're very happy with the community that we've built here. And we'd ask you to join us too. So thank you for your time. Flutter.dev and Dart.dev are the websites. And of course, you can find me at kevmoo.com. And I'm excited to answer questions. Thank you.